Happy learning! Today we're going to talk about rates of change and derivatives. All right, so let's get started by talking about the average rate of change over some interval. So the average rate of change of a function from x equals a to x equals b is this value. It's f of b minus f of a over b minus a. So where does this even come from, right? This looks like I just pulled it out of thin air. Well, let's sketch a graph. So suppose that this is f of x, and here's a, and maybe here is b. This value is the slope of the line connecting these 2 points. A f of a, and b f of b. This slope of this line is the change in y, so f of b minus f of a, over the change in x, which is b minus a. Okay, so if this was like our revenue function, and we were looking at different units, this would tell us the average change in revenue from selling the units, the number of units between these two values. All right, and so what we're going to be interested in is what happens to the slope of this line as b gets close to a. Right? So as b gets close to a, this line is going to eventually kind of just hug the curve. It's going to lie tangent to the curve. All right, and this is going to be called a derivative. So if f is a function defined by y equals f of x, then the derivative of f which we denote by f prime of x is the following. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so how is this related to what we just talked about? Well, maybe instead of writing a, let's write x. And how far away b is from x will be h. So this value is x plus h. So the numerator becomes this, and then x plus h minus x as our denominator, that's just h. All right, so we're taking the limit as this point gets closer and closer to x. What happens to the slope? That's called the derivative. And so to find the derivative, the first thing we should do, so we have f of x plus h minus f of x over h, and then we're going to evaluate a limit. So the first thing is find f of x plus h. So this is the composition of functions. So wherever we see an x in our original f function, we're going to replace it with x plus h. Okay? It's not just that we tack an h on it at the end. It's wherever we see an x. This is so important. Wherever we see an x in our original function, we replace it with x plus h. Okay? So that's our first step. Step 2, we're going to simplify the numerator. All right? So we'll take what we just got from part 1, subtract off the original function. All right, so we're going to simplify the numerator. Step 3, we're going to simplify the entire fraction. And then finally, step 4 is we're going to evaluate the limit. Okay, what we get at the end will have x's in it. It's going to be a function. And that function, we'll see, gives us the slope of what's known as the tangent line at any point along the curve. All right, so we'll talk about that more in a second. But let's do an example. If f of x equals 4x squared, let's find f prime of x. All right, so pause the video. Try to work through these 4 steps and see if you get the answer. Your answer should still have an x at the end. There should still be an x in your answer at the end. But there should be no h's, right? All the h's are going to go to 0. OK, welcome back from the pause. I hope it was a nice pause. First thing we need to do, let's find f of x plus h. So f of x plus h. Wherever we see an x in our f function, we replace it with x plus h. Okay? Parentheses are your friend. X plus h squared. Anything squared is that thing times itself. Okay? So this is 4x plus h times x plus h, which simplifies to 4x squared plus 8xh plus 4h squared. OK, step 2, simplify what we just got minus the original function. OK, f of x plus h minus f of x. That's what we just got minus 4x squared. So 4x squared plus 8xh plus 4h squared minus our entire f function. Minus 4x squared will cancel with the 4x squared. All right, one way to check our answer is everything from the original function should cancel with something from our expanded function. All right, and so this cancels with this, and we're left with 8xh plus 4h squared. Next step, we want to simplify what we just got divided by h. Okay, so that's 8xh plus 4h squared over h. And notice every term in the numerator has an h that we could factor out. And when we do that, it cancels out with the denominator. We're left with 8 x plus 4h. And then finally, we want to evaluate the limit as h goes to 0. Okay, so we just showed that f prime of x, the derivative of our function, is 8x. Okay, so derivatives play a big role in business, economics, physics, chemistry, biology, math, obviously. Basically, any field that has a graph, that involves graphs, derivatives are going to play a role. So different fields have different notations for derivatives. So in math, we use f prime to denote derivatives, but you might also see some other notation. So f prime of x is the same thing as y prime, which is the same thing as dy over dx, which is the same thing as d over dx of f of x, which is the same thing as d sub x y, which is the same thing as d sub x f of x. Okay, so depending on what course you're taking in the future or what field you're in, you may see different notations. All right, these ones on the left, these first four, are the ones that you'd mostly see in a math or a physics class. Okay, and so think back to earlier when we talked about at one point we talked about marginal revenues, marginal costs, marginal profits. We said that is the slope of the revenue function or profit function, what have you. It's one way to think of the marginal revenue is it's how much your revenue increases by that next additional sale. Okay, so suppose that the total revenue for a product is given by R of x. Then the marginal revenue right, how much our revenue increases by that sale of that next unit is the derivative of our revenue function. It's the limit as h goes to 0 of r of x plus h minus r of x over h, right? It's the change in revenue for that next unit. Okay, this says that the marginal revenue is the derivative of the revenue function. The marginal cost is the derivative of the cost function. The marginal profit is the derivative of the profit function. Okay, so marginal is another way to just say the derivative. Okay, so suppose our revenue function is given by this, where x is the number of thousands of units sold. Right, so x equals 1 would mean you sold 1,000 units. X equals 2 means you sold 2,000 units, and so forth. And so what I want us to do is I want to find the marginal revenue when 20,000 units are sold. Okay, so let's get the marginal revenue function. Right, our marginal revenue is the derivative of our revenue function. We need r of x plus h minus r of x all over h, and we'll evaluate that limit. Okay, I'm going to do it all in one step, but I'll kind of go slow. All right, r of x plus h, wherever we see in r, wherever we see in x, we're going to replace it with x plus h. Okay, so 100 x plus h minus x plus h squared. Okay, that's this first term. Minus our original function. For the love of God, you better have some parentheses, because that minus goes to everything over h. We got to clean up the numerator. Then we'll divide out by an h and then evaluate the limit. Our numerator is 100x plus 100h minus, okay, x plus h squared, FOIL. You can't just distribute the exponents. It's not how it works. So it's minus x squared plus 2xh plus h squared. I'm going to just distribute this through also, so it's minus, minus, minus. Minus 100x plus x squared all over h. All right, what cancels? Minus 100x cancels with 100x. And minus x squared cancels with x squared. So it's the limit as h goes to 0 of 100h minus 2xh minus h squared all over h. And there's an h in every term in the numerator. So we could factor it out and divide by the h in the denominator. And we get the limit as h goes to 0 of 100 minus 2x minus h. So wherever we see an h, we could replace it with 0, and we get r prime of x equals 100 minus 2x. This is our marginal revenue for any value of x. We want the marginal revenue when 20,000 units are sold. X is the number of thousands of units sold. So we want to find the marginal revenue when x equals 20. Okay, I didn't say it, but the units for revenue is also in thousands of dollars. So this next unit sold increases our revenue by $60,000. Okay, that's how we interpret it. This next unit sold, so going from the 20,000th to the 20,000th and 1, increases our revenue by 60 units, which is $60,000 in our case. So if we have a curve and we want to figure out what is the slope at any point on the curve, the way we do that is we put what's known as a tangent line to our curve. And at this point, the slope of the tangent line is the same thing as the slope of our curve. It tells us at what rate our curve is increasing or decreasing. And we get that information from the derivative. All right, so the slope of the tangent line to the graph of y equals f of x at the point a f of a. So this point would be at a, up here would be f of a. Is given by m equals the limit as h goes to 0. Right, m is our slope. Our slope is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. Another way to say that is m equals f prime of a. The derivative gives the slope of the tangent line. All right, so let's take a look at an example. Find an equation for the tangent line to the curve y equals x squared at the point 3, 9. Okay, and so we know the slope of the tangent line is given by the derivative. So we could get the slope with the derivative, and then we're given a point. So if we have a point and we have a slope, we'll just put our answer in point-slope form at the end. All right, so we need f prime of x. So f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Right, so this is equal to the limit as h goes to 0 of x plus h squared minus x squared over h. Okay. Anything squared. X plus h squared is the same thing as x plus h times itself. And then we could do some foiling, right? Distribute it out. This is equal to the limit as h goes to 0, x squared plus 2xh plus h squared minus x squared all over h. X squared minus x squared. 2xh plus h squared over h. The h cancels. And now we can evaluate the limit as h goes to 0. So you just sub in h equals 0, and we get 2x. So this is the derivative of our function. We need the derivative of our function at x equals 3. Okay, so the slope of the tangent line is 6. And now we're basically done with the problem because we have a point, we have a slope, we remember how to use point-slope form. And so let's write our equation of our tangent line in point-slope form. Y minus the y component of our point is equal to our slope, x minus the x component of our point. This line, if we were to graph it along with our curve, so just to give a quick sketch, would look like this. It would touch the point, just give it a little old smooch, and that's it. And then it's on its way. So at this point, it tells us at what rate our curve is increasing or decreasing. Okay? And so I want to show you one last thing today. It's possible that functions don't have a derivative. Okay, so there's certain properties of graphs that would lead the function to have no derivative. So the following are not differentiable, which means they don't have a derivative at x equals 2. Okay, so the first one has a discontinuity at x equals 2. And so it doesn't even make sense. What would this be the tangent line? Would that be the tangent line? It doesn't make sense to have a tangent line here. So this the reason it has no derivative is because of a discontinuity. All right, so if there's a discontinuity, then there's no derivative. Okay, the next example this function does not have a derivative at 2 as well. Why is that? Well, the slope of the tangent line, if we're looking from the left, appears to be negative. At the right, it's positive. What's the tangent line? Where is it in between? So there's no well-defined tangent line. Right? It could be this, it could be this, it could be this. Since there's no well-defined tangent line, there's no derivative. So if there's a corner, a sharp edge, there's no derivative. And finally, if we have a vertical line, right? If our tangent line is vertical, then the slope of a vertical line is undefined, right? The slope of a vertical line is undefined. So the derivative, which gives the slope of the line, would be undefined. So this is a vertical tangent. Okay, so if you have a corner or a discontinuity or a vertical tangent, the derivative is undefined at those points. Okay, so it's not always the case that there is a derivative. But if our graph is smooth looking, there will be a derivative. And then we could use the techniques to evaluate the derivative. Okay, well, that was our start of derivatives. There will be plenty more where that comes from. So smash that like button, and I'll see you next time.